Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 7. It says industrially, vanadium metal V, which is used in steel alloys, can be obtained by reacting vanadium pentoxide with calcium at high temperatures. The balanced equation for the reaction is as follows here. And then they say during an industrial process, 31,850 grams of vanadium pentoxide reacts with 2 times 10 to the exponent of 4 grams of calcium. Then 7.1 says state the definition of a limiting reagent. So we say the limiting reagent is a substance that is used up completely in a chemical reaction, right? So that's our definition for 2 marks. Then 7.2 says calculate the theoretical yield of vanadium. So when we're speaking of the theoretical yield, we want the maximum number of a product or products that can be produced. So in this case, we are looking for the maximum number of the vanadium, right? So another thing that you have to note, the theoretical yield is calculated in terms of the mass, right? But then one important thing to note again, this is 6 marks, meaning that in order for us to get to the theoretical yield, we first need to determine between these two reactants, which one will be the limiting reagent, right? So the first thing that we need to determine is which one is the limiting reagent, and then the limiting reagent will lead us to the theoretical yield, because now we have to compare the ratio of the limiting reagent to the ratio of the product that we are calculating the theoretical yield for, right? So now to calculate that, let's now observe this. So we have all of this, the information, and then let's now start on a new page and calculate. The first thing that we have to do here is obviously, as we have stated, determine the limiting reagent. So determine limiting reagent. So step number 1. Now, obviously, to determine the limiting reagent, we first need to calculate the number of moles of both this reagent. So we have vanadium pentoxide, which we can calculate the number of moles by saying mass over the molar mass. The mass we were given 31,850 according to our statement. Then the molar mass of vanadium pentoxide, we know how we calculate that one. Vanadium, according to our periodic table, is 51. So we have 2 atoms of vanadium, so that's 2 times 51. We have 5 atoms of oxygen, but oxygen is 16. So this will give us, so if we punch all that into our calculator, we have 182 grams per mole, right? So which we're going to put in here, 182. Now, punching all this into your calculator, you have 175 mole. Nice. So again, now we're going to calculate for the calcium, and then that's N is equals to M over the molar mass. So which will give us the mass we were given 2 times 10 to the exponent of 4. And then the molar mass of calcium, according to our periodic table, is just 40. So if we punch that into our calculator, we end up with 500 mole, right? But then we cannot just conclude that 175 mole of vanadium pentoxide is the limiting reagent based on the fact that it is the smallest number of moles. Because when we go back and look at the ratios there, we can see that the ratio of calcium, so we have 5 Ca that reacts with V5. Now looking at this, we can see the ratio of calcium to the vanadium pentoxide is 5:1. So what does that mean? For every 1 mole of vanadium pentoxide that react, we actually need 5 moles of calcium. So obviously with that ratio, we cannot just conclude that this one is the limiting reagent. That means we'll need to go further and prove it based on our ratios, right? So which will lead us to our second step here. So now let's prove that based on our ratios. So 2, let's compare the molar ratios. Compare the molar ratios. So now we say the ratio of calcium to vanadium pentoxide is 5:1. So for every 1 mole of vanadium pentoxide that reacts, we actually need 5 moles of calcium. Now, obviously, let's check how many number of vanadium pentoxide moles do we need to react in order to react all of that calcium. So we're going to put X here. Now, if we do the maths here, that's 5 times X, then 500 multiplied by 1, which will give us a 5X is equals to 500. Then eventually we have to divide both sides by 5. Now the X will be equal to 100 mole. But then what is the meaning of this? The meaning of this is that we only require 100 mole of the vanadium pentoxide to actually react with all of the calcium that is available. So note that the ones that I calculated here are the available number of moles. So this is what we have available of both the reactants. So now in order to react all of this 500 mole, we only need 100 mole. But then available, we have 175 mole. Now we know that once the number of moles required is actually less than the number of moles available, then that particular substance, so substance is the excess reagent. So if for that particular excess, for that particular substance, meant to say, the number of moles that is required is actually less than the number of moles that is available, then that means we are dealing with a substance that is the excess reagent. Now, in a reaction, out of 2 reactants, one will be the excess reagent and the other will be the limiting reagent. Now that we've proven that vanadium pentoxide is actually the excess reagent, so this here is the excess reagent. That means without any question, we can then conclude that the calcium in this case is the limiting reagent, because you can never have 2 excess reagent or 2 limiting reagent. It's one has to be the excess and the other has to be the limiting. So Ca is the limiting reagent in this case. Right. So now in conclusion, we can say again, if the N of the required is greater than the N of the available, so number of moles, then that particular substance is the limiting reagent. Right. Now you might want us to prove why we say this one is the limiting reagent. So we're just gonna do this one, but then this time around we check what number of moles do we need to react in order to actually react all of this vanadium pentoxide. So we're gonna have our X on the calcium side and then put the 175 here. We cross multiply this is X, then if we cross multiply this, 875 mole, if you punch it in your calculator. This is the required number of moles. Now, if we go back here, remember, if the number of moles required is greater than the number of moles available, then that means that particular substance is the limiting reagent. So check. We require 875 mole of calcium in order to only react with 175 mole, which obviously is telling you that this here is more than what is available. We are looking for 875 mole, but we only have 500 mole available. So obviously this again proves that calcium is the limiting reagent. So, okay, now let's not get carried away in the question. Remember, this is not what we were looking for. The goal of the question was to find the theoretical yield, right? So after we have identified the limiting reagent, we still need to continue with this question here and then find the theoretical yield. So for the theoretical yield, now that we have identified that calcium is the limiting reagent, remember we said we must take the ratio of the limiting reagent to the ratio of the product. So Ca, the product that we are looking for is vanadium. Now, again, according to our balanced equation here, we can see that the ratio of the calcium to the vanadium will be 5:2, right? So that means we have 5 here, and then we have 2. But then remember, we already have the available number of moles of the calcium is 500. Then we're going to put our X here in order to find the products or the number of moles of the vanadium that has been produced. So if we cross multiply, that's 5x. Cross multiply here, that's 1000. Divide both sides by 5. Then our X is just 200 mole. But then remember, we said that the theoretical yield is in terms of mass. So we still need to go further here and say N is equals to M over big M. Note that we are calculating for vanadium V. Now the number of moles is 200. We are looking for the mass, but the molar mass of vanadium is 51 according to our periodic table. We cross multiply here, our mass becomes 10,200 grams. Remember, our mass should be in grams, so we leave it like that. So that's how we calculate the mass of vanadium pentoxide, the theoretical yield. So the next question, they're saying calculate the percentage yield if 8.67 times 10 to the exponent of 3 grams of vanadium is obtained. Now the percentage yield, and as you can see here, that is only for 2 marks. So a straightforward question. Now, obviously, in order to calculate that, you'd need to know how we calculate the percentage yield. So percentage yield is equal to the actual yield over the theoretical yield. So now you can understand why it's 2 marks, because you are actually given the actual yield, and then you have calculated the theoretical yield in 7.2. So it's just a matter of substituting into that formula and then multiply that by 100. Okay, so that's 8 point, because if they say if 8.67 times 10 to the exponent of 3 grams vanadium is obtained, so this is the actual yield. This is what has been actually obtained. So now the one that we actually obtained was 8.67 times 10 to the exponent of 3. But then the one that we had projected to get was 10,200. So that's the theoretical yield. Then multiplied by 100. Now we find that of what we obtained versus what we expected to obtain, it is only 85%. So that's your percentage yield. Awesome. So that's how you were supposed to tackle this question. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.